Okay, so we're moving along now. Let's borrow some concepts from the previous lesson, but let's upgrade them. Let's change them around a little bit. Those concepts would be these hard constraints, as you saw. It's the body. They didn't break, right? They don't have a strength threshold like the glue does that breaks. So one thing I would say is we can arbitrarily break them ourselves. Let's see. So if I go into the sim here, we've got our constraint network guy. Now we can also, kind of like with the way we have our rigid body solver has a SOP solver, we can give him a SOP solver also. So let's do that. And this was always going to run though. We don't need to like enable or disable this one like we did with this. So we go over here. I'll put an out just for good measure. We're not going to use this DOP geometry thing. We're going to actually use relationships. Constraints are considered relationships. So this is actually where our constraints are. Once again, we don't see them, but that's because they're here. Remember, they're just a bunch of points right now. So let's run the sim a little bit. Let's run the sim a little bit so that we get to some kind of smashing area, just where it hits the ground. Boom, boom, boom. There we go. Good enough. So I'm going to stop it and make sure that it doesn't start again. So as we move, these never move. When it's showing us them in the over here, when we scrub it and it can like show us the guides, that's just the guide. That's just a convenience where it's moving them into place based on the pieces that they are constraining together. But in reality, they never actually move. They just stay here at whatever the first frame was. So that's cool. More importantly, the different constraints use different kinds of data. Glue is concerned with impact strength. So as it receives impacts, that's what it compares to the strength and will break it if it so feels like it. So there we go. But our hard constraints use other things. The hard constraints don't care about impact at all. They have force and distance. Force meaning the amount of force that was applied to it in that time step, and the distance is essentially how far it moved from its original location. So these are useful things to say, well, if the force is greater than some number, break it. Or if the distance is greater than some number, break it. And you break it in the same manner where you can add it to the group broken primitive group, and then the solver will take care of itself. So we can just do that. The other thing we can borrow from the previous lesson is the idea of using glues to permanently glue stuff together, meaning never break. Just make more complex objects out of two things that are infinitely strong. So in the glue area here, I'm going to change this down to 1. Because remember, any incoming parameter, like our strength or whatever, is going to be multiplied by this. So it's easier to keep in track if this is set to 1. That way, anything we pass in, we just know is going to be multiplied by 1. So the glue just got a lot weaker, but we can now populate this stuff with default parameters, let's say, that will be multiplied by that instead. So for example, let's just make a template of all the possible things we might want. Let's start with the glue that we were just talking about. Cat glue strength. So let's say we just got rid of 10,000, so let's put 10,000 back here. So now it's 10,000 times 1 will be the old glue strength, essentially. And remember, everything we put in these is going to propagate down. Nope, it's already doing it. And be promoted back up. And then this process constraints is going to set them. So whether the same thing we did it with the constraint name, every piece will have its preferred glue strength, and then it will take the smaller of the two when it gets to here with this minimum thing, when it goes from the point to the primitive, because the primitive is the constraint domain. All the attributes on the primitive are where the actual constraint attributes are stored. And then this will take our cat things and convert it. So let's say for f strength will equal cat glue strength. because only the glue constraint uses the strength attribute. So going back here though. So this is the default, and remember we'll be able to override with any number of these other property things. In fact, we're going to make a few, so I'll just make some room now. Cool. So we got the glue strength. What else we want here? We're going to want. We just talked about distance and force. So let's say cat hard break distance. You saw how low those numbers were before. So a small, let's say a low amount. This is actually pretty high, so it'll take a little bit to actually break it. And then similarly, we could have it break through two different means. It could break because of distance, or it could break maybe because of a sudden force. Cat hard break force. That would make more sense. As usual, you can call these whatever you want. It's just as long as they are assigned to the expected attributes down the line. So we got all that. And then, like I was saying, we'll also want to make specialized glue constraints for clustering. And what I like to do here is say some percentage. So we'll say, if I said 0.15 here, that would mean 15% of the constraints will be permanent, unbreakable constraints. So you'd want to have lots of pieces, and then maybe like 5, 10, 15% of those pieces will be glued to each other, just to make more interesting pieces. You'll see what I mean. You might have a whole bunch of glass pieces like here on the windshield, maybe even more than this, but you might want to have this, every few of them will be connected to each other to make just, irregular shapes. They're not all just like regular Voronoi stuff. Very cool. So those are our defaults. So let's just wholesale copy and paste this thing over and over again and change it however we see fit. So here's body props. So this was at cat name equals body. I guess I could have just copy and pasted the text inside of it, but anyway. So like I said, we want that to be hard, which means it's not even really going to use the glue one, so we can actually just get rid of this one here. It doesn't really matter, just save space. We also don't need it to cluster in this case, but we might have it do maybe we'll just change this arbitrarily, like, hey, the break distance is 15 instead. I don't know, something like that. I could just keep it there, and then we might copy and paste it again. So what else we need to do? We might want to work on the glass, the windows. So I'll just say like windows props. And I don't even really remember what I called that one. So I'm going to go here. Apparently I did call it windows. So you do that thing and you just have it do it for you. Because we might as well make sure that this one's the right one also, just in case I typed it wrong. Cool. So windows would be glue. So the default is glue already, so we don't even need to have this here. Instead, we would have all we would need is the strength. The glass is pretty brittle. So I would say if 10,000 is the default, maybe it should be 100, something like that. And we would also want it to cluster for sure. I would actually say that the clustering probably by default should not be anything. We don't want it to cluster by default, but the windows we do. So that's 0.15. We could do the rotors. The rotors might have their own kind of settings. So we'll say rotors, and we can select them just to make sure that we're getting it. Cool. The rotors, they could probably be pretty strong. Maybe I'm gonna keep this here. I know it's the default, but I definitely do at least want it to cluster a little bit, so we'll just keep that there. And we'll have this here, we can conveniently change it later rather than relying on the default. And then maybe the only other one I would think of is maybe this the top and the tail, we could even do it once. So I'm just gonna copy and paste that one. Say top and tail, or you might break it out into two. It's up to you. And I'll grab him, then him. Oops, him and him. So we have the top and tail. And I would say for that one, let's make that one be a hard one. So it's like more, maybe it's a bendier one. So we'll say, oops, I grabbed glue, but that's fine. So hard. And maybe he also clusters for some reason. Cat cluster equals 0 point. We'll say 1, just to keep it, and to mix it up. So even having the clustering within a sea of hard pieces could be interesting still. You'll just have bigger chunks that are bending with smaller chunks. So it could be interesting.